Hello, everyone. Thank you for joining us today for our technical training. I'm Renata Kalnionene, Marketing Project Manager at MedDream. Today we have a theme which is dedicated to MedDream scaling for high availability. And thank you for joining us. As usually, our technical trainings are being recorded. All the registrants will receive video recording in a few days after this technical training, and of course, with presentation file. Also, I invite you to ask your questions in the question and answer section. I will collect the questions and read them at the end of the webinar. So today we have a main speaker, Marius Šadauskas, our speaker for technical trainings, who is system integrator at MedDream. So main part is by Marius, and also we have Artūras Gruodis as a help for us in the question and answer part. He will help us to answer your questions. So Marius, are you ready?
Yes. Hello, everyone. Let me share a screen and let's start our webinar. I think now you should be able to see my screen.
Yes.
Okay, so today webinar is about the MedDream scaling for the high availability. So short agenda of this training is in general, the architecture overview of the MedDream scaling and what components it includes to have the scaling for the high availability. As one of the main components is the session management, so the configuration with Redis or Valkey service will be also gone through this presentation, so how to configure the MedDream Viewer and the token server with the service with the Redis or Valkey, and we will go through MedDream and AWS HealthImaging high availability demo, and of course your questions. So the first part, let's go through the components and the architecture overview. So here is just, very briefly, would say the workflow of how this scaling and high availability architecture would look like. So in principle, the user connecting from any of the devices goes to the MedDream through the load balancer, which then redirects to running multiple MedDream nodes. Let's say you have, I don't know, 5, 10, or more nodes of the MedDream running, and the load balancer moves you to one of these. And as you can see, we have two main components, which are the common components for all the MedDream instances running. So it is shared storage for the MedDream cache, and there is a Redis or Valkey service which is used for the session and log management in this case. So the components consist of the load balancer, which in our experience now more and more clients uses the cloud solution. So in principle, if we talk about the biggest components like AWS or Azure, so they have their load balancers, and they are working just fine. So, and not only these companies, other load balancers as well. What else you need? Of course, the MedDream Viewer nodes in the stateless mode, the token service if you are planning to use the secure URL integration. So this one also is required, and the shared fast storage. So it would be a centralized storage for the MedDream cache. So all the MedDream instances, multiple MedDream instances, would be using the same cache, and wouldn't need, to have a separate cache for each node and do some, synchronization and so on. So one centralized storage is recommended, of course, as fast as possible. So if we talk again about the cloud, so it could be AWS Elastic File System, or in the Azure the premium files, or let's say if you have on-premise server, or if you run some virtual machine, so the fast SSD disk would be a good start. And of course, we need Redis or Valkey for the centralized session and log management. So for this also, as I saw, many of the cloud providers have this already offer this as a service. So you do not need, to install it separately. You have a Docker or a virtual machine running only for the Redis or Valkey. You can simply use their service, which should be, I would say, mm, good solution and reliable. And MedDream scaling for the high availability in principles ensures that there will be no single point of failure, and the MedDream and the MedDream token service can be scaled horizontally. So from one to many MedDream nodes or MedDream token service nodes could be running at the same time. And there is a consistent user session across all nodes. And there is, of course, safe concurrent access to the cache and log files, uh, because the Redis or Valkey is used and the shared disk is used. For the load balancer, so in principle, just some information, but as mentioned, mostly all load balancers would suit your needs. In principle, what it needs to do is just to be able, to forward HTTP or HTTPS traffic to MedDream nodes. It should have, some health checks option available. So it could check, MedDream service is up and running, and the sticky sessions in this case are not required because the sessions are stored in the Redis or Valkey service. And having this deployment, this configuration with all these components, in principle, would behave as follows: that if one of the MedDream or MedDream token service node would fail, so the traffic would be routed to the remaining nodes, and the users do not lose the session. The session would simply exist in the another node, and that user would be able to browse the MedDream, view the studies seamlessly, and cache would also remain consistent across the all nodes because it would have the shared storage disk, and the system can be scaled horizontally by adding more nodes if needed. So depending on, especially if you run on the cloud, so you can have this scaling rules, set by the usage of CPU, by usage of memory. If the CPU is higher than X% for, I don't know, 5 or 10 minutes, scale to 5 MedDream instances. If it is goes down, so scale to 2 MedDream instances, and so on. And if we talk about, let's say, higher load, bigger installations for the high availability, and not only for a high availability, but in general, even if you use one MedDream instance, so it would be good to think about it, and we would recommend it to use two separate MedDream Viewer pools, if we could say that. So imagine that one of the set of MedDream viewers, a separate pool, is used only for the caching the studies to prepare them in advance. So, for example, you are pre-caching the studies using instance availability notification messages, or using the DICOM listener, or using preparation GMS service, caching via backend, or some other scenarios. So it would be wise to use a separate MedDream for this, which would be responsible only for the caching. And then you would have a separate pool of MedDreams, which is used for the users to view a study. So for the doctors, for the patient practitioners, or whoever is opening the studies in the MedDream Viewer and view them. Using this approach with different MedDream pools gives you, I would say, more flexibility, because you can scale them differently according to the load, or also the queues for the jobs and everything are the separate. So this is also good even for standard installation where you are not planning to scale the MedDream viewer. Also, this, for example, caching MedDream pool could be used also for the temporary cleaning. So let's say you configure your temp cleaner to remove the cache older than 1 week, 2 weeks, 1 month, and so on. So for this also you could use the caching MedDream pool for this, and the other pool for the users would remain, without any additional workload, only the workload from the users who opens and view the studies. And as I mentioned, one of the key components here for the scaling is the Redis or Valkey. So before going to a deeper example of the configuration, so there is some requirements to be able to run MedDream for high availability. So all your MedDream nodes, which you will be running, they must use the same configuration. So if you are using the application property, system JSON, global JSON, so all these configuration files, I don't know, rebranding or any other files, everything must be the same. And nodes must be in the stateless, running on the stateless, and a fast shared disk should be used, as I mentioned it, for the storing MedDream temporary cache files and so on. And regarding running these multiple instances of MedDream with the scaling option, so in order to scale MedDream horizontally, you must have contractually agreed license options that allows you to run multiple instances of MedDream Viewer on the same application server. So if you are planning to do this, or if you want, to test it, so please contact our sales. They will give you more information, the pricing model, and all other technical information which you need. They will provide you, and you can discuss them about this licensing option for the scaling of the MedDream Viewer. Now let's jump to the more technical thing about the configuration of the MedDream Viewer. And I will provide here a few examples how to configure MedDream Viewer with the Redis or Valkey. So first example is the one if you are using, for example, MedDream, install it on your Windows, Linux, or if you are running even the Docker installation, but you have the application properties mounted. So all your settings is stored in the application properties files, and you do not use this environment variables. So in this case, in principle, what you need to do is to add additional Spring profiles, because most probably in your MedDream you will already have, let's say, out his, out in memory, out SAML authentication Spring profiles or something like that. So you will add two additional ones, Redis and stateless. And you need to provide these four parameters for the secure key, encryption, password, and salt. And this is very important information here. These are publicly available values because they will be available in this webinar. They are available in our installation manuals, in integration manuals. So if you are planning to use this, do not copy paste these values. Generate your own secure password, secure salt, and secure key, and change these values because they are available in our documentation and everyone can see it. After adding these parameters in MedDream, it's also important in our latest MedDream 8.9.0. We have a new parameter redis.config.server. So in this line, you will provide the, say, single line of your Redis URL. So in principle, this part remains the same. You only need to change this part with the IP address and port. So here, of course, could be a host name. If it is a secure version of Redis, so it will be Redis S with additional S letter here, and so on. But this is a new property, and new property in application properties, how to provide the URL of the Redis. So these are mandatory settings to have enabled Redis in the MedDream, and we have also this additional manage endpoint which you could open, and you can include the health manage endpoint on which you can check the health status of MedDream. So of course, again, you need to put a strong username and password, and you will be able to access manage endpoint and check the health checks. So here would be an example of the URLs of these manage endpoints if you would enable this management IP port and all these other settings. So after adding these settings to application properties, what you need to do is restart the MedDream service, and MedDream will connect to your Redis or Valkey servers, and basically it will be done. So for this, I can try quickly show you. I have the application properties here prepared. I have these lines also added here, so I will uncomment it. Save the file and start my MedDream service. If I want, I can try to check on my logs. Let me clear them to see that it is starting. And once it starts, moment, logs are not coming, but they will come. Yes, because I'm running 8.8 version, I need to run 8.9. Yes, so MedDream is starting, and of course you do not need to check the logs. Just I want to show you that there is lines, where it shows that it connects to the Redis service, and you will be able also to see in your Redis service as well that the connection appears. So here, as you can see, the Redis is connecting, and it is connecting to that address which we have provided in the application properties file. So if I will check on my test Redis environment for client list, I will be able to see that I have the clients, which is the in this case, this MedDream Viewer, which are connected to my Valkey service, which is running on the separate Docker image. So like this, you can run this and on 8.9 version and test it. Of course, first you need to check that you have the firewall enabled, that you can access the logs, the Valkey or the Redis service from the MedDream, and then it will connect automatically. Now for the previous versions, so in 8.8 version and 8.9 version, we didn't have this Redis config server parameters, so you would need to add only these values. So I will demonstrate you here. So in the application properties on 8.8, I will uncomment these values, save it, and I will start the MedDream Viewer for 8.8 version. And if I will come back to the files, you will be able to see in a few seconds that it actually creates a file. Redis config file, one moment. Once it will start, it will create a Redis YAML file, which needs to be here. As you can see, it have created Redis YAML file automatically. And if we will check it, you will see that there is a default value, default redis.127001 and the port. So with older version, 8.8, 8.7, you will use this configuration, and you need to update this line in the file, put the correct IP, correct port, save the file, and restart MedDream service again. Because if the MedDream will not be able to connect to the Redis, so it will fail to start. It will show you the error that it cannot connect to that IP and the port. So this is a differences between the versions. So depending on which versions you will use, so keep in mind this. Another example here is for the AWS. So if you are running MedDream on Elastic Cluster Service and you are using environment variables instead of application properties, so everything you have is on environment variables. So what you need to do is to edit your ACS task, create a new revision, and add the same properties just as environment variables. So as you can see, it is done by making them all capitals, and instead of dots, there is a underscore. But you will be able to copy this from the presentation. Once again, change these values to the more secure. And for the Redis config server configuration, you need to provide this as a JSON with these, special characters, and just change Redis URL to your actual Redis service or IP or whatever service you will be using. So this is also in MedDream Viewer 8.9. If you will be using the older MedDream Viewer, you need to use Redis URL environment variable instead of Redis config server, and you need to provide only the URL. So this is a change in 8.9, so you need to check this when you will be deploying. And another example of the configuration, if you are running on Azure Kubernetes cluster on AKS, so you are also not using application properties, you have the YAML files which you apply to the Kubernetes cluster, and the MedDream is deployed. So in this case also, here we have provided the not application properties, but the environment variables, how they need to be set, and the Redis config server can be set in the following manner. So you will be able to take this from the slides after the webinar. And also, this Redis config is in 8.9 version. In older versions, you would use Redis URL and provide only the URL of the Redis with the IP or hostname and the port. And once you do this, of course, you will redeploy, reapply on the AWS or Azure, and it will start. It will connect to your Redis or Valkey service. The next step, if you are running the secure URL integration, so you might want to use token service with the Redis or Valkey. So for this, it is similar. If you are using application properties file, so you need to edit this application properties file. Just for the including the profile, as you can see here for token service, we need only Redis profile, and you need to provide secret key and initialization vector. So these also are available in our installation and integration manual. So change these values to your own values, but keep in mind that exact lengths are important, and the secret key should be 32 characters, and the initialization vectors should be 16 characters. And the Redis config parameter is the same as in the MedDream. So once you add this, restart MedDream token service, and it will connect to Redis or Valkey server or service, and you will be good to go. And one important thing, advantage of using the token service with the Redis or Valkey. So if you run it like this, and for example, you restart a token service, so all the generated tokens will remain in the Redis, of course, while they are not expired. But in principle, if you restart the token service and there is some tokens generated, after the token service comes, it will work just fine, and you don't need to generate a new tokens. While in the standard installation, if you will restart token service, so all the tokens would be lost, So this is also one of the advantages to use the Redis or Valkey service. And for the older token service, it is also the same. If you add these parameters, these three parameters, the Redis YAML config file will be created in the token service installation directory. You need just to edit this file, provide the correct IP and the port, and save the file and restart token service. Here is also example of MedDream token service running on the AWS Elastic Container Service. So it is also here you can see what are the environment variables used for the initialization vector, encryption secret key, and what is the value of the Redis config server. And for the older token service, which is older than 2.123, you need to use the token Redis URL parameter and provide only the Redis URL and port, IP and port. So this is also check which version of the token service you will deploy. So it will depend if you will use Redis config server parameter or token Redis URL. The same goes to the Azure Kubernetes cluster. So you will have parameters here. As you can see, parameter string profile is provided like this in Kubernetes clusters. Here is some other profiles for the token service. Also, you would provide the secret key, IV vector, and the Redis config server or the token Redis URL. So in principle, these are all the um, configuration settings regarding the Redis and Valkey. How to configure your MedDream, how to configure your token service, so you can try it, test it to see how it works and play with it. And now I want to shortly present you the MedDream and AWS HealthImaging high availability demo. So for this, I will go to the internet, and you can find our GitHub account or MedDream account in the GitHub. So you can just Google MedDream AWS HealthImaging DICOM Viewer or find us through the GitHub. And we have this project, AWS HealthImaging DICOM Viewer. Maybe some of you already have seen it, and maybe some of you have already even deployed it. So basically, the idea of this infrastructure is also very similar to what we have presented. So I'm not going to read through all these documents. I'm just going to highlight some things. You will be able to see it yourself. So as presented in very first slide with the architecture overview, so basically, as you can see, we have the similar thing. So the users are connecting to MedDream through load balancer. Of course, here in this case, in this CDK example, we have the CloudFront in front of the load balancer. So for this, you could consider, the CloudFront is good, and it would be wise to choose it and to deploy it if you plan to that your studies will be accessed frequently. I mean the same studies. So, for example, I don't know, you would have a training for a few days. You will be training, I don't know, 100 doctors. How to use the MedDream, and they all will be accessing the same studies. So for this, it would be an option to also use the CloudFront, because it would also cache these studies in the CloudFront, and it would open faster. But if you have a doctor who will be opening the studies, I don't know, once or twice, and that's it, and he will forget about these studies, so then maybe CloudFront is not needed. Because for this, you would also need to think about some session validation things. So you would need to know that the user is actually connected to the MedDream, so you would be able to show him the cached files from the CloudFront and so on. So this is considered depending on the situation, if you need the CloudFront or no. And the rest is the same. From the load balancer, it goes to the MedDream token service, which is running token service MedDream Viewer. It is running on the ACS cluster, so it can run multiple tasks or multiple nodes at the same time. It is auto-scaled according to the load, to the memory usage, to the CPU usage. It is using the shared file disk. So in this case, elastic file system, which is fast and reliable in this case. It also uses Amazon Elasticache, which is the Redis or the Valkey service. Also, it has some additional components like AWS HealthImaging for the storing the DICOM files, some buckets for storing additional configuration. Sorry, and so on. So, as you can see, this infrastructure is similar to what we have presented, but it has, I would say, more things to offer. So this deployment script you can run in your environment, and if you have the AWS account, you can simply run this and install it. It has even the multi-availability zone support. so you can run in multi-availability zones. It is explained how to secure it between the CloudFront and load balancer if you will be using it for the production. So you might want to you will need to do this, and there is prerequisites what is needed to install it. There is the main cdk.ts file where you indicate how you name your MedDream stack, what MedDream viewer images you want to deploy. If you want to enable the integration, for example, you want to enable token integration, study integration, or maybe you are not planning to use the integration at all, so you can disable it. You can provide the data store. You can enable sample data. So once everything is deployed, you will have some sample data already available in the data store, and you will be able to see how it opens in the MedDream. So all these settings are configured, and then here is the list of the components, resource types, which would be deployed in your AWS account. So you can see how many services, how many nodes, tasks would be deployed, and check this table, which is quite big. And for the installation, we also have steps, the prerequisites. You will need the Node.js at least 18 version, AWS CDK, AWS CLI, of course, AWS account with the proper permissions, and basically all the commands which you need to run. And once you run these commands, it will install and deploy this whole infrastructure, so you will not need to worry about the opening ports, firewalls, security groups, target groups, and so on. Everything will be deployed. It will be done approximately in 25-35 minutes, and at the end you will see all the list of the URLs which you can access, the CloudFront URL, the load balancer URL, so you will be able to open it and to see how it works. And for those who don't want to see on their infrastructure how it works, so you can come to our website. If you click on the online demo, as you can see here in the middle, we have a new button, AWS Online Demo. So if you will click it, you will go to avsmedream.com. So this is the infrastructure, which is actually this deployment scheme. So it is deployed here, so you can see, how the studies are opening, how they are working. Also, usually we use the latest release candidates here, so you can see maybe some new features which will get introduced and so on. So, principle, I would recommend to check this and see how it is working. And if you want, you can deploy it for free in your AWS environments and to see how it works. So this was everything from the presentation. So I'm getting back to you, Renata.
Okay, thank you, Marius. Thank you so much. So I'm going to share my presentation. So we got a few questions before the technical training. The first one, what is the differences for scaling on cloud or on regular VM on-premise servers?
So in principle, I would say on the cloud, it is easier to scale regarding the scaling rules, because on the cloud, when you have the cluster or pool, you can create the rules. For example, if the CPU is higher than, I don't know, 80% for a few minutes, start more nodes or more tasks of the MedDream. If the load is slower, then you can decrease it after some time and so on. So I would say regarding this, you need to think how you would be scaling, or you will just use you will just run 5 or 3, MedDream instances, and that's it, and you are not planning, to scale them up or scale them down. So I would say maybe this would be the main difference, how you will scale it.
Okay, so I'm going to read next question, yes?
Mm-hmm.
Okay, I would like to be given a very rough way to estimate required resources on the host PC. For example, for a system that may have 1, 2, 5, 10 doctors concurrently, how many
Mm-hmm.
compute resources would I need for a smooth experience?
Yes. So, in principle, in our website, we have the minimal server requirements. So, but it will depend on the studies, If you have a standard small CT-DX studies, so you can follow these minimal server requirements. But if you have like I don't know, enhanced CT studies or mammo studies, which are the big ones, so you might consider having much more resources for your MedDream instances. So basically, I would say it will very depend on the situation, on what studies, what type of the studies you have. But the first point would be to check our minimal server requirements, on our website.
Okay, thank you. Next one, do we need MedDream high availability license for every node that we deploy, or do we purchase a single high availability license that allows us to deploy all our necessary pools and nodes?
For this, maybe Arturas can comment, or it's a
Yes,
question for Jamus.
you will get one license which will be used for all nodes.
Okay, so I am going to the next question. By enabling MedDream's own caching functions, where we have several endpoints that will perform caching based on those endpoints, can I still use MedDream's HA mode? Can we guarantee the functionality of caching and HA with a Kubernetes cluster?
Yeah, in principle, it will work. Yeah, uh, we have this tested, and some clients are running it on Kubernetes. The main idea is to have run it on the Redis or Valkey, and to have the same shared disk between all nodes.
Okay, so I'm moving to the next question, yes?
Yes.
Okay, I will try to read the next one, but I'm not sure about this shorten slang. Let's see. Do you provide KAs resource, WAML examples, other templates, customize, Terraform?
No, currently we don't have these examples ready or something like that.
Okay,
But
next one.
you can check, how it's. We have the Docker examples with environment variables. So if you know how to create it on YAML, so you will adapt, or if you will have some questions, you can always contact our support, and we will guide you how to do this.
Okay, next question. Have you tested in Google Cloud GKE standard or autopilot clusters? Is it able to connect to Google Healthcare API?
This Google GKA standard or autopilot clusters, no, we have not tested. And regarding the Google Healthcare, so yeah, we have this working for many years, I think, using this DICOM web protocol. So it's explained in our installation manual how to configure MedDream with Google Healthcare API. But regarding this autopilot cluster, I think personally we have not tested. Other clients maybe.
Okay, the next question. Is the GitHub AWS setup using multiple MedDream pools for splitting up caching, viewing, and cleaning up as you described before?
This AWS deployment on the GitHub, as I remember, no, it will use one MedDream viewer. Yes, yeah, it will use one MedDream viewer. So it will use if you will send to it, so it will use for caching, for cleaning, and viewing. So this we will not have, but you can create, just another task definition, another task or pool. I forgot how it's called in AWS, and create a separate one for the caching and cleaning.
Okay, so the last question. Just a reminder, if somebody else wants to ask something, write a question now, because I'm reading the last question we got. What about support of HA for Azure Health Data Services?
Yeah, it is working with the Azure Health Data Service, and we are also actually running we have tested, Azure Kubernetes cluster, and we connected with the Azure Health Data Service. So it is working.
Okay, thank you, Marius, for answering the questions. If somebody has more questions, of course, please contact us, write directly to your sales account manager, to our support, and let's continue on this theme. As I promise, all the registrants will receive a video recording and this presentation Marius presented, joined with the questions. And also, I'm going to use this opportunity to announce that next month we are going to have integration webinar with two partners. One will be our partners in Italy, Medsto Sorano, with a radiology information system solution, and another one, AI for CMR, cardiac AI solutions. So this is already published on our website, and you will soon see on our social media and receive the newsletters. Thank you everyone for joining. Thank you, Marius, for presentation. Thank you, Arturas, for help. And again, thank you everyone for joining. I wish you to have really nice the last days of the summer, and great start in autumn in September.
Thanks,
So thank
everyone.
you all.
Bye.
And bye.
Bye.